This is my sixth video lesson for Unit 6B. In this lesson, we'll be determining the limiting reagent, theoretical, and percent yield. Go to page 22 in the class packet. Motivation: you are working at a burger joint. The recipe for a double cheeseburger is 1 meat patty, 1 bun, and 2 cheese. If you only have 4 meat patties, 4 buns, and 7 cheese pieces, how many double cheeseburgers can you make? What is left over and what is used up? So here is a picture showing the recipe. 1 meat patty plus 1 bun plus 2 cheese is 1 double cheeseburger. So here's a visual. If you only have 4 meat patties, 3 buns, and 7 cheese pieces, you can make 3 burgers. But notice we have some left over. We have 1 meat patty left over and 1 cheese piece left over. We used up all the buns. In the previous lesson, I have been using the analogy that stoichiometry is similar to cooking. Whenever you follow a recipe or make a dish, you always calculate how much product you can make, what ingredients you will use up, and what ingredients you have left over. The cookbook will always state how much you can make based off this recipe, and then you can scale it based off how much you want. We do the same thing in stoichiometry. The recipe is our chemical equation. We can calculate how much of the reactants will be used up, and that'll be the limiting reagent. We can calculate how much products we can technically make from the reaction, and that'll be our theoretical yield, and how much we actually make in the chemical reaction, and that'll be the percent yield. Learning target. At the end of the lesson, I will be able to determine the limiting reagent and calculate the theoretical yield and percent yield. Homework B number 6, which will be a junior part based off this lesson. Theoretical yield is the amount of product made based only on the limiting reagent. From the motivation, the theoretical yield was 3 cheeseburgers. The excess was the meat patty and the cheese pieces. Notice that the buns were used up. In every recipe, the amount you can make is limited by the least amount in your recipe. This is known as limiting reagent. Limiting reagent is the substance that is totally consumed when the chemical reaction is complete. So in the case of the motivation, that would be the bun. The theoretical yield is only based off the limiting reagent because that's the ingredient that is used up in every chemical reaction. The ones that are not used up are called excess. So in this lesson, we'll learn how to identify the limiting reagent and calculate the theoretical and percent yield of a chemical reaction. In task number 1, it is identifying the limiting reagent. Here we're given a chemical equation. What is the limiting reagent if we start with 27 grams of Al and 71 grams of Cl2? The procedure to do this is on page 22 in the class packet. The first step is to convert all the reactants to moles. The reactants are Al and Cl2. We convert to moles by dividing it by the GFM. For Al, we have 1 mole, and for Cl2, we have 1 mole as well. Even though they have the same amount of moles, it does not mean there's no limiting reagent. Remember, the proportions are based off the chemical equation, so we have to use mole ratios to determine the limiting reagent. The next step is to do a mole ratio between each reactant and the product. So the first one will be Cl2 and AlCl3. Based off the chemical equation, the mole ratio is a 3:2. Since we have 1 mole of Cl2, we have 0.67 mole of AlCl3. Now we do the same thing for the other reactant. If we compare Al and AlCl3, based off the chemical equation, they are a 2:2 ratio. Since we have 1 mole of Al, we have 1 mole of AlCl3. Notice if we compare both mole ratios, one of the reactants produces much less products than the other one. Since Cl2 will produce less product than Al, Cl2 will be used up before Al will be. So the answer is Cl2, which is the limiting reagent. In summary, the one that produces the least amount of product is the limiting reagent. So the procedure is to first convert all the reactants to moles, then do a mole ratio between each reactant and the product, and the one that produces the least amount of product is the limiting reagent. You can also draw a picture to help you visualize it. Here we have equal amounts of Al and Cl2 based off the table, we know Cl2 is the limiting reagent, therefore it will be used up before Al will be. So as you can see, the Cl2 was used up, and the Al, we still have excess left over. I am going to do the next question as an example. In question 1b, what is the limiting reagent if we start with 54 grams of Al and 71 grams of Cl2? The first step is to convert every reactant to mole. This time, we have 2 moles of Al and 1 mole of Cl2. Next is to do a mole ratio between each reactant and the product. So let's start with Cl2 and AlCl3. Based off the chemical equation, the mole ratio is 3 to 2. We have 1 mole of Cl2. Therefore, we have 0.67 mole of AlCl3. For Al versus AlCl3, the mole ratio is 2 to 2 from the chemical equation. This time, we have 2 moles of Al. Therefore, we have 2 moles of AlCl3. Since less product is formed with Cl2, the limiting reagent is Cl2 again. This should make sense because if we compare with the previous question, in which both reactants have 1 mole, aluminum was the excess reactant and Cl2 was the limiting. Learning check number 1. What is the limiting reagent if we start off with 81 grams of Al and 71 grams of Cl2? Pause the video and resume once completed. So the answer is choice 2, Cl2. So the first step is to convert everything to moles. We have 3 moles of Al and 1 mole of Cl2. Then we set up a mole ratio. And once you finish setting it up, you can see that Cl2 produces the least amount of product, therefore it is the limiting reagent. Learning check number 2, what is the limiting reagent if we start off with 54 grams of Al and 213 grams of Cl2? Pause the video and resume once completed. So the answer is choice 3, no limiting reagent. So the first step is to convert everything to moles. We have 2 moles of Al and 3 moles of Cl2. Next, we sub a mole ratio. Notice in both cases, we produce the same amount of product. Therefore, everything will be used up and there is no limiting reagent or excess. Learning check number 3. What is the limiting reagent if we start off with 27 grams of Al and 213 grams of Cl2? Pause the video and resume once completed. So the answer is choice 1. So the first step is to convert everything to moles. We have 1 mole of Al and 3 moles of Cl2. Next, we sub a mole ratio. This time, aluminum produces the least amount of product, therefore the limiting reagent is aluminum. Now I want you to finish up all the problems in task 1 on your own. Pause the video and resume once completed. So here's the answers. For 1C, the limiting reagent is Al. For 1D, there is no limiting reagent. For 1E, the limiting reagent is Cl2. Here are the answers to question 2. Now that we know how to determine the limiting reagent, we can now calculate the theoretical yield. Remember, the theoretical yield is based off the limiting reagent. Question 3a is the same question as 1a, which was the first question we did about the limiting reagent. So the limiting reagent in this question was Cl2. As you can see from the mole ratios, Cl2 produces the least amount of product. Therefore, 0.67 mole of AlCl3 is the theoretical yield. Now we're going to convert it to mass. To do that, we multiply by the GFM, which is 133 for AlCl3. 0.7 mole times 133 gives us 88.67 grams of AlCl3. So this is the theoretical yield, or the max amount of product that can be produced from 27 grams of Al and 71 grams of Cl2. So how much reactants are left over? Since Cl2 is the limiting reagent in the reaction, it is used up during the reaction, so we have 0 grams of Cl2 left over. For AL, we must determine how much was used during the reaction. We're going to do a mole ratio between Cl2 and Al to figure out how much was used during the experiment. The mole ratio between Cl2 and Al is 3 to 2 from the chemical equation. Since 1 mole of Cl2 was used up, 0.67 mole of Al was used up. In the beginning, we have 1 mole of Al, therefore 1 minus 0.67 is 0.33 moles left over. How much mass is that? 0.33 times the GFM of Al is 8.91 grams of aluminum. That's how much aluminum that's left over from the experiment. Learning check number 4, if we start off with 81 grams of Al and 71 grams of CO2, what is the theoretical yield of AlCl3? Pause the video and resume once completed. The answer is choice 1. To compare this with the previous question, we have the same amount of CO2, but triple the amount of Al. If you recall, CO2 was the limiting reagent of the previous question, so adding more Al is not going to change that. Therefore, the theoretical yield should be the same as the previous question. So let's prove that. From the mole ratios, you can see that CO2 is again the limiting reagent. Since theoretical yield is based off the limiting reagent, the theoretical yield will be 0.67 mole. We have to convert it to mass, so we're going to multiply by the GFM, which is 133 grams over mole. So the theoretical yield is 88.67 grams of AlCl3. As an extra, how much reactants is left over? Since CO2 is the limiting reagent, it's going to be 0. This time, we should have more aluminum left over because in this question, more aluminum was used in the previous question. So first got set up a mole ratio between CO2 and Al. Based off the chemical equation, it is a 3 to 2 ratio. In this reaction, we use 1 mole of CO2, therefore 0.67 mole of Al was used up. In the beginning, we have 3 moles of AlCl3. 3 minus 0.67 mole gives us 2.33 mole left over. To convert it to mass, we do 2.33 times the GFM of Al, which gives us 67.9 grams of Al. That's how much mass of Al was left over. Learning check number 5, if we start off with 40.5 grams of Al and 213 grams of CO2, what is the theoretical yield of AlCl3? Pause the video and resume once completed. So the answer is choice 3, 199.5 grams. So the first step is to figure out the moles of each reactant. Here we have 1.5 moles of Al and 3 moles of CO2. Next, we sub a mole ratio between each reactant and the product. The limiting reagent in this question will be Al because it produces the least amount of AlCl3. So the theoretical yield will be 1.5 mole of AlCl3. To convert to mass, we're going to multiply 1.5 by the GFM of AlCl3, which is 133 grams per mole, and we get 199.5 grams of AlCl3, and that is the theoretical yield. Now I want you to try to do question 3B to 3F on your own. Pause the video and resume once you want to see the answers. So here's the answers. For the last part of the lesson, we're going to talk about percent yield. So let's look at learning check number 6. You are making a batch of cookies. According to the recipe, you have enough ingredients to make 100 cookies. After baking, you actually only managed to make 90 cookies. What is your yield in terms of your percentage? So percent yield is the actual yield over the theoretical yield times 100. Your theoretical yield is 100 cookies. That's based off the recipe. what you actually made was 90 cookies. So 90 divided by 100 times 100% gives us 90%. That is your percent yield. So now we're going to include percent yield in our calculations. In question 4a, the reaction was performed using 16 grams of CH4 and 32 grams of O2. The student managed to synthesize 5 grams of H2O. What is the student's percent yield? So the first step is to figure out the limiting reagent. The next step is to figure out the theoretical yield based off the limiting reagent. And then you can calculate the percent yield, which is the actual yield over the theoretical times 100. To figure out the limiting reagent, we must first figure out the moles of CH4 and O2. They are 1 each. Next, you set up a mole ratio with each reactant with the product. It does not matter which product you use, you will get the same answer. So I'm going to set up the mole ratio with water. So as you can see, O2 produces the least amount of water. Therefore, O2 is the limiting reagent. And 1 mole H2O is the theoretical yield. We have to convert it to mass. The GFM of water is 18. So 1 mole times 18 gives us 18 grams of H2O. And that's the theoretical yield in this experiment. The percent yield is the actual yield over the theoretical yield. So 5 over 18 times 100 gives us 27.8%. That is the percent yield. Now I want you to do the rest of the problems on your own. Pause the video and resume once you complete it. So here's the answers. So this concludes the video lesson for today. Remember to do the Junipod homework.